In this video, we're going to talk about how to find the mean and standard deviation of probability distributions. The mean, and here we use the Greek letter mu, also called the expected value of a probability distribution, is the long-range average outcome of a repeated experiment. And the formula we have to find the mean is we take the sum of each outcome multiplied by its probability. And the way we would write it like this is capital sigma x times p of x. We can also find standard deviation of probability distributions, and we have these two formulas for that. Generally, I think the first formula is a little bit easier to use. I'll show you why when I go through the calculations. The second formula also works, and if you prefer it, you're welcome to use it. The first example, I'll show you how to do it with both formulas. Other examples, I'll be sticking to the first one. Let's look at an example. We want to find mu and sigma, or we want to find the mean and standard deviation for the given probability distribution. So if you remember our formula for the mean, it's the sum of each x value times its probability. So we'll make another column over here for multiplying each x value by its probability. So we have 0 times 1 over 8 is 0, 1 times 3 over 8, 3 over 8, 2 times 3 over 8 is 6 over 8, and 3 times 1 over 8 is 3 over 8. Now we need to add all of these up to find our mean, and this ends up adding up to 12 over 8, or 1.5. Now we'll find the standard deviation using the first formula we have written down, which is this one. So in order to find the standard deviation using this formula, we have to find the mean first, which we've already done over here, so we'll have to square that and plug that in there later. And now we need to find each x value squared times its associated probability. So now we'll go back here, take each x value, we're going to square it, and then multiply it by its probability. And now that we found all of these, we can find the sum, and that's equal to 24 over 8, or 3. And now we have enough information to plug everything into this formula. So we have 3 minus 1.5 squared, take the square root of that. This works out to be radical 0.75, which works out to be 0.8660. Should always round standard deviation to 4 decimal places. Now we'll take a look at how to find standard deviation using the other standard deviation formula. So here's the other formula we have for standard deviation. We also have to find the mean for this one, which we found before. So what we need to do here now is take each x value, subtract the mean. We need to square this number, then multiply it by the associated probability. Then after that, we'll add them all up and take the square root. And remember, we had a mean of 1.5. So first we have 0 minus 1.5 squared times 1 over 8. Then we have 1 minus 1.5 squared times 3 over 8. 2 minus 1.5 squared times 3 over 8. 3 minus 1.5 squared times 1 over 8. Now we just need to evaluate each of these, and we end up with 9 over 32, 3 over 32, 3 over 32, and 9 over 32. And the sums to 24 over 32. So now for our standard deviation, we just need to take the square root of 24 over 32, which is equal to the square root of 0.75, which is equal to the same thing we got before, 0.8660. Okay, so here's another example. Find the mean and standard deviation for the given probability distribution. I would suggest pausing the video, try to work this one out on your own, then hit play to see me go through the answer. First thing we need to do is find the mean before we can try and find the standard deviation. So to find the mean, we need to take each x value, multiply it by its associated probability. Then we add these up, and we end up getting 6 over 11. So our mean is equal to 6 over 11. Now we want to find our standard deviation. I'm going to opt to do this using the first formula because I think it's a little bit easier, but you should get the same answer even if you use the second formula. So we need to square each x value now and multiply it by its associated probability. So we have 0 squared times 5 over 11, which is 0, and then 1 squared times 6 over 11, which is 6 over 11. And then we add these up, and we end up with 6 over 11. Now we have enough information to plug everything into the standard deviation formula. And we get a standard deviation of 0.4979. Now let's look at another type of problem. Here we want to find W, the missing probability value in the given probability distribution. In order to do this, we need to remember a particular fact we had, that the sum of all of the probabilities in any probability distribution is always equal to 1. So if we know that adding up all of these probabilities has to equal 1, we can use that information in algebra to figure out what W is supposed to be. Now all of these should add up to 1. Now we just need to do a little bit of algebra. We end up getting 0.77 plus W is equal to 1. Subtract that from both sides. And we end up getting W is equal to 0.23. We need to use that type of technique in order to solve problems like this. So here we're being given a probability distribution. They're asking us to find the missing value. Then they're asking us to find the mean and standard deviation. And then they're asking us to construct something called the probability histogram. So for part A, we have to make use of that fact. So we set this up. We see 0.3 plus 0.5 plus whatever W is has to be equal to 1. So we end up seeing 1 is equal to 0.8 plus W. And we end up seeing 0.2 is equal to W here. That was information we needed in order to figure out what the mean and standard deviation is, and then later to construct a probability histogram. So now we want to find our mean, and in order to do that, we need to multiply each x value by its associated probability and add them up. So we have 2 times 0.3, 4 times 0.5, and 5 times 0.2. If we add all of these up, the mean is equal to 3.6. The next thing we want to do is find the standard deviation. So in order to find the standard deviation, we want to square each x value, then multiply it by its associated probability. Then we'll plug everything into this formula. And we add all of these up, and we end up getting this is equal to 14.2. Now we have enough information to plug into our standard deviation formula. And we end up getting a standard deviation of 1.1136. Now for part C, we want to construct a probability histogram. And we construct this similar to how we would construct a regular histogram. We're going to have our possible outcomes on the x-axis, and we're going to have our probabilities on the y-axis. Now you want to think about using a scale that makes sense for our probabilities. I'm going to count by 0.1s. And along the x-axis, I'm going to write a 0 over here. Even though we don't have a possible outcome of 0, there are some examples where you will have a possible outcome of 0. They want you to make a probability histogram, and you would draw a bar for it over here. But here it's not going to get a bar because it wasn't an outcome in this experiment. But we still need to use a regular scale for this. And we can count by 1s, because all the values we have are fairly close together. Now the only possible outcomes we had that showed up in this experiment were 2, 4, and 5. So these are the only values that are going to get any bars. The other values won't get any bars because they're not outcomes in this experiment. So the outcome of 2 had a probability of 0.3. So that's going to be the height of its bar. 4 had a probability of 0.5, so that'll be the height of the bar it gets. And 5 had a probability of 0.2, so that's the height of the bar it gets. And everything here is everything you would need to have when constructing a probability histogram.